So section 2 of chapter 7 is basically the opposite of the first section. So in the first section, we named chemical compounds given their formula. Now you're going to be given the name in English and you'll have to write the formula. So the same 4 rules are used in this section. It's just kind of backwards, as I said. So the first rule is still writing formulas for binary compounds. So just remember that a binary compound is one which is made of 2 elements. And the rule is basically similar to the rule in 7.1, but now we're writing symbols instead of names. So the first step is to write the symbol of the first element from the periodic table, and then you follow it with the second element's symbol. And remember, a symbol can be either one capital letter or a capital and then a lowercase letter. And it's important to make sure you're capitalizing and lowercasing appropriately. So after you've written the symbols, you will then need to consult your periodic table and check the charges. So you should have recorded the charges on your periodic table in the beginning of this chapter. And then basically what happens is the charges have to cancel out. So if they do not equal each other, you crisscross them, and the charges then become a numerical subscript. Sounds complicated, quite easy once you see it. Okay, so let's try some examples of binary compounds. So the first example is potassium iodide. So you first need the symbol for each of these. So potassium is K, and iodide is iodine, which is I. So that's the first step. Write the symbol for the first element, followed by the symbol for the second element. Notice I'm writing them close together. The second step is to check the charges. So looking at my periodic table, potassium is in group 1, so it has a charge of +1. I'm going to write that above. And then iodine is in group 17. It has a charge of -1. And these equal each other. They cancel out. +1 - 1 equals 0. So my final answer would just be rewritten, capital K, capital I. And I write them close together, and remember, we don't write subscripts of 1. It's assumed there's one of each, but we don't write it. Try another. Aluminum nitride. So binary compound, 2 elements. So aluminum is Al, nitride with nitrogen, so capital N. Now I check the charges. Aluminum is +3, and nitrogen can either be a plus or -3, while the second element is always a negative charge. So in this case, it's going to be -3. And once again, these cancel out, so I just rewrite it without the charges, AlN. Okay, what happens if the charges don't cancel out? So we have Li for lithium, the charge of +1. And we have O for oxide, oxygen, with a charge of -2. So in this case, these charges do not cancel out. So we have to crisscross them. So what's going to happen is the 1 is going to become the subscript of oxygen. So lithium's charge becomes oxygen's subscript, just the number, not the plus or minus. And then oxygen's charge becomes lithium's subscript. So you just crisscross the actual numbers. So my final answer is now Li with a subscript of 2, I crossed it over, and then O with a 1, which we don't write because I crossed that 1 over. So that's my final answer. If you actually put the charges back on top, you can check that they cancel. So -2 times subscript of 1 gives me a -2 overall, and a +1 times a subscript of 2 gives me a +2 overall. So they do cancel out. So once again, my final answer is just Li2O. So that's why there's sometimes subscripts, even though you don't use a prefix. It's because the charge is having to cross. Okay, try one more. Sodium sulfide. So sodium is Na with a charge of +1. Sulfide is sulfur, S, with a charge of -2. Once again, because these do not cancel out, I'm going to crisscross them. So the 2 will become sodium's subscript, and the 1 will become sulfur subscript. So my final answer is Na2S1, technically. Okay, so if the charges don't cancel, you crisscross them and make them subscripts without a plus or minus. If the charges do cancel, you don't write anything. So up here, the plus and -3 canceled. I don't write Al3N3. It's not needed. Up here, the 1 and -1 and +1 canceled. I don't write the subscripts. You only write subscripts if you're canceling charges by crisscrossing. Okay. Try these ones. Pause your video, and then we'll come back and show you the answers. Okay, so the first 3 are pretty similar. So calcium fluoride, Ca is a +2, F is a -1. They crisscross to give us CaF2. Same trend is followed with strontium bromide and barium iodide. The first element has a +2 charge, the second element has a -1. So strontium bromide, SrBr2, from crossing those charges, and then barium iodide, BaI2. Okay, the bottom one's a little challenging. So magnesium, Mg, has a charge of +2. Phosphide is phosphorus, P. Remember, we're just doing binary elements. So just from your periodic table, P has a -3 charge. Comes second, so it has to be negative. So I just crisscross them. So the 2 from magnesium becomes phosphorus's subscript, and the 3 from phosphorus becomes magnesium subscript. So I'm left with Mg3P2. And just to show you again, if I plug these charges back in, -3 times the 2 subscript gives me a -6 overall. A +2 times the 3 subscript gives me a +6 overall, and they cancel. Okay, so that is binary compounds. Write the elements, write the charges, crisscross to cancel if necessary to make subscripts. Okay, next up we have writing binary compounds that include prefixes. So in 7.1, this was a slightly challenging rule because you had to consult your periodic table special combinations. In this section of the chapter, you don't need to consult the back of your periodic table for the special combinations. They're given to you in the names. So these are very easy to identify. You just have to remember what the actual prefixes are. So we start the rule very similar to the binary, or actually identical to the binary. We're still looking at 2 elements. So you say that, you write the symbol of the first element, you write the symbol for the second element, and then, depending on the prefix given to you in the name, you just add the subscript that matches that prefix. That's it. You do not check charges because the name tells you the prefix, which tells you the subscript. That's what you use. You're not going to check charges because that will change the subscript and it won't match the name that's given to you. Okay, so let's try some examples. Up real quick, just remember that 1 is mono, 2 is di, not bi, we use di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 hepta, 8 octa, 9 nona, 10 deca. So if you don't have those on your periodic table, you'll probably want to copy those down unless you really are confident with them. Okay, so let's try some examples. Very simple. Okay, first example, tetraphosphorus decaoxide. So the first thing I'm going to do is figure out what are my elements. So I've got phosphorus and oxide, which is oxygen. So I know I'm going to have a capital P for phosphorus and an O for oxygen. Now I need to figure out the subscripts. Tetraphosphorus means I have 4 phosphorus. So I'm just going to write a subscript of 4 after the P. Decaoxide means I have 10 oxygen. So I write a subscript of 10. and that's it, you're done. You do not check the charges. So this is very simple compared to what it was in 7.1. All right, try another. Dinitrogen monoxide. So the first thing is to figure out what elements are being represented, because remember, it's still always 2 elements in this case. And then what does the prefix represent as far as a subscript? So I have dinitrogen monoxide. So I have nitrogen N and oxide for oxygen O. Di means 2, so I have 2 nitrogens, and mono means 1, so I have 1 oxygen. We just don't write the 1 subscript, and that's it, you're done. What about this one? Dinitrogen pentaoxide. Well, once again, we have nitrogen and oxygen. In this case, we have di, again, 2 nitrogens, except now we have pentaoxide, penta meaning 5. Once again, super simple compared to what it was. Do not check the charges. Okay, carbon dioxide. Well, I know I have carbon, and I know oxide, oxygen. Dioxide means 2 oxygens, but what about carbon? It doesn't have a prefix. Well, remember, if the first element's prefix is mono, it's not stated. It's just assumed it's 1. So carbon is 1 in this case. Oxygen is 2. It's very simple. All right, try these ones out on your own. Pause the video, try these out, and then we'll go over the answers. Okay, so check your work. The first one was probably the trickiest. Carbon monoxide. I have carbon and oxygen. Once again, remember, if the first element does not have a prefix, it's assumed it's 1. So it's just capital C, capital O. And it's very important that you capitalize appropriately, because if you write something like this, that's not carbon monoxide. That's capital C, lowercase o. That's cobalt, the element. Very different things. So make sure you're capitalizing and lowercasing your letters appropriately. Triphosphorus heptabromide would mean 3 phosphorus, 7 bromide. So P3Br7. Sulfur hexafluoride, sulfur S. Fluoride is fluorine F. No prefix on sulfur means it's 1. And then hexafluoride 6 fluorine, so SF6. And then dinitrogen trioxide, N2O3. So once again, this rule is much easier than it was in the previous section because the prefixes are given to you in the name. You don't have to consult that special combination chart, and all you do is just write the symbols, write the prefix as the subscript. No checking of charges. So this will probably be the easiest rule of this section.